Hey everybody, sorry I could not be there today to present this to you myself, but I had to stay home and keep my water heater from exploding in my basement. Not really, but dripping. And so anyway, today we're talking about basic types of measurement. So we know there are two systems of measurement out there in the world today. We've got the English system and the metric system. The English system is kind of a misnomer because while it may have started with kings in England, there are only 3 countries in the world today that actually use the English system, also known as the Standard Measurement System: Liberia, Myanmar, and us, the United States. If you want to know where Liberia and Myanmar are, look them up. Since science is a global process, since we talk about scientists using, sharing their work and publishing their work so that other scientists can do the same types of research, we have to realize that science needs one system so that everybody can communicate effectively. So science, just like the vast majority of the world, has chosen the metric system. Hopefully, you'll find this to be a lot easier than working with fractions in the English system. So yesterday, I had you do a discussion about types of measurement and how they're measured. And I want to go over what types of measurement actually means. Types of measurement means things that you can measure about an object or an event. So types of measurement are length. You can measure the length of something. Volume, mass, temperature, force, weight. These are just a few of the things we know as types of measurement. So when you think types of measurement, think what about the object are you actually measuring? Then you have tools and units that you use to do the measuring with. So we've got units of measurement. Notice they are not the same. The unit of measurement for length is the meter. The unit of measurement for volume is the liter. Mass is the gram. Temperature, we use Celsius. Force, we use newtons. And weight, we either use newtons or kilograms. So when you're asked about types of measurement, think about, okay, what about the object am I actually measuring? What property am I describing with this measurement? Our first type of measurement to focus on is volume. So the goal here is making sure everyone knows what volume is, making sure everyone knows what units we use for volume, and finally making sure everyone knows the 2 ways that we go about measuring volume and that you can actually do it. At the end of each of these measurement lessons, you will be taking a quiz that in order to move on, you have to pass the quiz. That quiz will involve some multiple choice type questions, but it's also going to involve some actual measurement. So it's really key that as you're going through this, you pay attention, you study, and you practice. All right, so let's go into detail about volume. On your notes paper, if you're looking at the top of the page, you should see this same information. Find where it says which is larger. If we compare the English and the metric units, we've got things like 1 liter of water or 1 gallon of water. Think about those 2 for a minute. If you look over on my side table, you'll see a liter bottle, and it used to have water. I think it says Smart Water on it, and it's marked 1 liter. And you've seen a gallon of milk. Which is larger? Well, a gallon. A gallon holds almost 4 liters of fluid. 3 3/4. So this also goes in your notes. Find the spot where you tell me how many liters to a gallon we get. Then if we think about 1 liter or 1 quart, maybe you're not as familiar with a quart, but a liter is bigger than a quart. A liter, well actually a liter and a quart are almost the same size. You've got 1 quart of oil in the picture and you've got 1 liter of water in the picture. A quart is about 0.946 liters. If we rounded it off, they're about the same. Finally, if we look at a small amount of volume, liquid volume, 1 milliliter, or what we know as 1 ounce or 1 fluid ounce. In that case, 1 fluid ounce is the greater volume. If you look at a can of soda, the can, and you can see one again on my side counter there by the window, the can of soda is 12 ounces, but that's 355 milliliters. So a milliliter is significantly smaller than an ounce. So now that we've compared a little bit, let's talk about what volume is and how we got this term. Continue taking notes. You're filling in the blanks with the bold terms here. Volume is the amount of space an object takes up. So the more space you take up, the more volume you have. It has nothing to do with mass. It has nothing to do with how heavy the object is. The volume of a styrofoam block is much greater than the volume of a steel marble. The base unit for volume is the liter, and you abbreviate liter with a capital L. This is the only abbreviation base unit where we use a capital letter, and if you abbreviate it with a lowercase letter, it will be wrong. So capital L for liter. The standard amount for a liter is a cubic decimeter. This is the only time where we find two different measurements being equal. So two different types of measurement. We can measure volume using a graduated cylinder. So that would be for liquid volume. You see a bunch of those on the table there, or on the counter. Or we can use a ruler to measure the volume of regular objects, things that have equal sides, or things that are nice and squared off. So 1 liter is equal to 1 cubic decimeter. A cubic decimeter would be a box that was 10 by 10 by 10 centimeters. That's equal to 1 liter. The metric units. Remember that the term milli stands for 1,000. So 1 liter equals 1,000 milliliters. Notice here it's lowercase m, capital L. Make sure you abbreviate correctly. 1 milliliter is also equal to 1 centimeter cubed, or cubic centimeter, cc's. If you've ever watched a medical show and they say, give me 15 cc's stat, that means they want 15 milliliters, or 15 cubic centimeters, which is also, when you refer to water, equal to 1 gram. This is crazy because we have units of volume, units of length, and units of mass all being the same. That doesn't happen any other time. Alright, so if we look here and we're just comparing metric units, which is larger, 1 liter or 1,500 milliliters? Well, in this case, 1 liter is less than 1,500 milliliters because 1,500 milliliters, or 1,500 milliliters, is greater than 1,000, and 1 liter is equal to 1,000 milliliters. If we look at 200 milliliters or 1.2 liters, 1.2 liters is our greater amount. 1.2 liters, if we converted it to milliliters, which we will learn how to do later, would be 1,200 milliliters. Finally, 12 cubic centimeters, go back up here, that equals 1 cubic centimeter is equal to 1 milliliter, so that'd be 12 milliliters, or 1.2 milliliters. Well, in this case, 12 cubic centimeters is much greater. So that's a little comparison between metric volume units. Now for the tougher part. When you use these things called graduated cylinders, you have lines that are marked with numbers that represent however many milliliters you're looking at, and then you have lines in between. So just like when we did our graph the other day, we are looking at finding an interval. We're looking at figuring out, well, okay, how many milliliters is each of these lines worth? Is it worth 1 milliliter each, or 2, or 5? You can't always assume that they're worth the same amount because they will not be. And part of the difficult part in learning how to measure volume is figuring out the interval on your measuring tool. So to do this, first you find the difference between two sequential numbers, which means subtract. So I might find the difference between what I know to be 40 milliliters and what I know to be 30 milliliters. The difference there is 10. So I know there are 10 milliliters between these two marked lines. Then count the lines between those same two numbers. So if I look here again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 40 would make 10. So I have 10 lines between those two numbers. 10 lines between 40 and 30, 10 lines between 40 and 50. Then divide the difference by the number of lines. So 10 divided by 10 gives you 1. That means each line is worth 1 milliliter. So that was an easy one to figure out. Not all of them are that easy. I do want to point out that usually the line that's in between, that's halfway, that line is usually a little bit longer than all of the rest. So it makes it easy to figure out, okay, what's halfway. Here's a quick video showing you again how to read graduated cylinders. Pay close attention. This is what kids find to be the hardest thing to do.
Video, we're going to learn how to measure liquids accurately and precisely using graduated cylinders. Learn how to measure liquids accurately and precisely using graduated cylinders. It's very important when you measure any type of liquid, you use a graduated cylinder like these. You do not want to use a beaker or a flask because those aren't calibrated to measure liquids accurately. So stay away from beakers and flasks. I know they have hash marks on them, but those aren't as accurate and precise as a graduated cylinder. Those are just general estimations. So if we look at our two graduated cylinders here, we have a large one and we have a small one. Each one is different, so it's always important to pay attention to what type of graduated cylinder you have. So the hashes for each one can be different. So if we look at the large one on the right, the larger hashes are 1 milliliter markings and the 0.5 milliliter markings are smaller hashes. So that's for a larger graduated cylinder. And if we look on the left, we have a different hash system. So the larger lines are 1 milliliter markings, but the smaller ones are now 0.2 milliliter markings. So when you take measurements, you want to take it to the 10th place. So for example, 8.5 milliliters would be a good reading rather than just 8 milliliters or 8.52 milliliters. So if we fill both of these graduated cylinders up, let's try to take an accurate measurement of the two liquids. Okay, so if you look at the hand on the screen, now my little pointer, let's try to measure out the volume on the smaller graduated cylinder. So if we look here, this line here is a 7 milliliter mark. So if you remember, these little hashes are 0.2 milliliter marks. So this is 7, 7.2, 7.4, right? The meniscus looks like it falls underneath the 7.4, so you could say an accurate reading would be 7.3 milliliters. Okay? Now, if you said 7.4, that's not bad. Okay? That's acceptable. So now let's look at the graduated cylinder on the right. Here we have 15 milliliters. And if you remember, these hashes, right, they're hidden here. Each one represents 1 milliliter. So if this is 15, this one is 16, there would be one that's here 17, 18, 19, 20. Right? And if you remember, the ones in the middle are 0.5. So if this is 15, this is 15.5, and then this would be 16. And from 16, this is 16.5. And up here would be 17. So it's very difficult to see a meniscus here, but it should fall somewhere within this range. So if this is 15, this is 16, and then 17's right here, you can probably say the meniscus is somewhere in here. Right? It's a little difficult to see. You can kind of see a little bit over here. Now you can say an accurate reading for this would be, if this is 16, this is 16.5, maybe somewhere around 16.8, because the meniscus is definitely under the 17 milliliter mark. So 16.8, 16.9 milliliters would be a good reading for the graduated cylinder on the right.
So that gives you an idea of what different types of graduated cylinders look like and how carefully you need to look in order to read them. You will see graduated cylinders with both of these intervals. So you will see intervals at 0.2, like they showed on the left. You will also see intervals with 0.5, like they showed on the right. And you'll see graduated cylinders with intervals of 1 milliliter and possibly 2 milliliters. So just realize that you're going to have to get in the habit of finding the interval of your graduated cylinder first, and then you can read the amount that's in it. So we'll be using graduated cylinders to find the volume of liquids and other objects. Read the measurement based on the bottom of the meniscus or the curve. This is what the individual was talking about in the video. So here is a good picture of a meniscus. You can see that the curve of the liquid, because of its cohesion and adhesion properties, it makes the liquid stick to the sides of the glass graduated cylinder, and you end up with this dip or this curve. So the volume of water in this graduated cylinder is how many milliliters? If we look at our intervals, we've got intervals of 1 milliliter. Here's 5, so that would be 45, 50 would be up here. Our meniscus falls right at this third line. So we can say that the amount of water in the graduated cylinder is 43 milliliters. How about these examples? We've got example A, B, and C, and again, please make sure you're filling in your notes. What's the volume of water in each cylinder? Take a look. So starting at the bottom, we can see that our marked hashes are marked by tens, and then we have a number of lines in between. Let's count the number of lines in between. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you count the next marked line, so we've got 10 lines between 30 and 40. 10 divided by 10 is an interval of 1. Then we go up to where our reading is. And for these examples, I did not give you a meniscus to read at, so it just goes straight across. But in the real world, you would see liquids with a meniscus. So it appears here that our reading is 2 lines above the 50, making that 52 milliliters. If we move to graduated cylinder B, now our interval is slightly different. We have 5, 10, and 15 marked, and then how many lines do we have between 2 marked lines? So we have 1, 2, 3, 4, and you always count the last one as 5. So in this case, between 30 and 35, we have 5 lines. So that's 5 divided by 5, which gives you an interval, again, of 1. But notice how the interval of 1 here looks very different from the interval of 1 here. That makes this measurement 35, 36, 37. 37 milliliters. Just want to point out one more thing. When you abbreviate the term milliliter, L is capital, M is lowercase. Here's our final example. Here we have way fewer lines to work with. So our marked lines are 5, 10, 15, 20, but we only have 1 line in between them. So that means the line in between has to be halfway between 20 and 25. So we've got a 5 divided by 2. Not divided by 1, but divided by 2, because we count from here, we start 1 and we finish at 2. So 5 divided by 2 gives you an interval of 2.5. So that means if the liquid were here, it would be at 20. The next line up is 22.5, but you can see that the liquid goes slightly above 22.5. You could estimate at 23 milliliters. So that's how you read some examples of graduated cylinders. Take a look at our next measurement. Remember, you can also find volume by measuring. If you have something nice and rectangular like a box, you can also find volume by measuring length times width times height. So the volume of this cube would be 10 times, remember to multiply, not add, 8 times 9 centimeters. We also have to multiply the units. 10 times 8 times 9 gives you 720 centimeters cubed, also known as cubic centimeters. So what do we do if we have an object? It's not liquid, so we can't just dump it in a graduated cylinder and read it there. It's not a rectangle, so we can't measure it with a ruler. We have an object like this rock. There's another way to measure volume of irregular objects, objects that don't have nice straight sides. And that would be called water displacement. So we're going to basically look at, remember volume is how much space something takes up. So if we put the rock in a graduated cylinder, we're going to look at how much water this rock moves. How much water does it get out of the way so it can be in the water? And that would be equal to the volume of the rock. To do this, you have a little bit of subtraction. It's not difficult, you can do it. So you start by looking at the amount of water in the graduated cylinder that does not have the object. If we read this, let's figure out our interval here. So our marked lines are by 100, and then we've got 1, 2, 3, 4, 5. So 100 divided by 5 gives me an interval of 20. Each line is worth 20 milliliters or 20 centimeters cubed. So we start with, here's the amount of water before I put the rock in. That's 200 milliliters. Then I put the rock in and I look at where it reads now. So here's 200, our interval is 20, so 220, 240, 260, and maybe a little bit above 260 depending on your angle that you're looking at. So we're going to go with 260. The amount of water with the object is 260 milliliters. The amount of water that we started with was 200 milliliters. And then to find the volume of the rock, we just look at the difference. How much did the water go up? Well, it went up by 60 milliliters. So the rock over here has to be 60 milliliters of volume, or 60 cubic centimeters. So this brings us to the end of measuring volume. We've got finding interval, we've got measuring volume in a graduated cylinder, we've got measuring solid volume either using the formula or by water displacement. Your next task, if you turn your paper over, at the top of the page there is a section that says Station 1 Schoology. You're going to practice finding some volumes using a website on Schoology, and I'll take you there now. So if you open Schoology, and navigate to the metric system, in the measuring volume folder, the presentation we just went over, if you want it in slideshow form, is right here under measuring volume presentation. And the first website that you need to use in order to do the backside, Station 1, is this measuring volume required. So when you click there, you should see the Math 6 Spy Guys. and I'm going to mute my volume so you can keep hearing me. You're going to go through this lesson on your own, filling in the answers to the questions on the back of your paper. Have a great day. Make sure you behave, and I will see you tomorrow.